In this tutorial, we are going to be focusing on the valence electrons. When we said valence electrons are simply the electrons in the outermost shells or energy levels of an atom. They are the electrons involved in chemical bonding and the interactions with other atoms. The numbers of valence electrons determine how an atom will bond with other atoms and what kind of compound it can perform. In simple words, we can say that valence electrons are simply the electrons which are found at the outermost levels or energy of a shell. Next thing we have is the core electrons. Core electrons, on the other hand, are the electrons in the inner shells or energy levels of an atom. These electrons are involved in chemical reactions or bonding with other atoms. They are tightly bounded to the nucleus and play a role in maintaining the stability of the atoms. In this case, we can say the core electrons are other electrons or any electrons apart from the valence electrons. This is what we call an electron shell. The first one is being labeled by K. We have the second one, which is L. We have the third one, which is M. And the next one which we have is the N. And the next one which we have is the O. When we said an electron shell, this simply refers to the energy levels or orbit around an atomic nucleus where electrons are likely to be found. Let's look at the electronic configuration of oxygen. Let's say oxygen here we have 8 on the top, which is the numbers of electrons and the protons. Down here, which is the atomic mass or the mass number, which is 16. In this case, the first shell or the electronic configuration of the oxygen is simply going to be 1s2, 2s2, and 2p4. Notice that the first shell we have carries 2 numbers of electrons. Therefore, we're going to have 1 and 2. And the second shell carry 8 numbers of electrons. But if you have less than 8, it's okay. But preferably, or it shouldn't exceed 8. If here we have 6 because 2 plus 4 is 4, 4 plus 4 is simply going to be 8, which is the numbers of the protons and the electrons. In this case, if we put 2 from the inside, which is first shell, which is K, which share the same boundaries with the nucleus. So the second shell, we're going to be left with 4. Here we're going to have 1, 2, 3, and the last one, which is the fourth one. In this case, we can say these 2 are what we call the valence electrons because those are the numbers. Sorry, here we have 4. We're simply going to add 2, which make it 6. In this case, we can say these 2 are what we call the outermost shells or the valence electrons. Let's try the second one, which is hydrogen. Hydrogen, it has 1 electrons and 1 protons. In this case, the electronic configuration for hydrogen is simply going to be 1s1. And we're going to have just 1 shell carrying just 1 numbers of electron. What about the next one? The next one we have here is carbon. If you notice on the top carbon, we have 6. Down here, which is the atomic number, also the numbers of electrons and protons, which is 6. Down here we have 12, which is the mass number. In this case, the electronic configuration for carbon is simply going to be 1s2, 2s2, and 2p2. Therefore, we're going to have 6. If you notice here, we said the first shell simply carry 2 numbers of electrons, or 2 electrons, which is 1 and 2. 2 multiplied by 3 is simply going to be 6. 6 minus 2 is simply going to be 4. In this case, we'll be left with 4. I'm going to put 1, 2, 3 here, and the last one, which is 4. If you notice here, in the case of the oxygen, our valence electrons is simply going to be 2, 4, is simply going to be 6. In the case of oxygen, our valence electrons is simply going to be 1. In the case of carbon, our valence electrons is simply going to be 4. What about problems like neon, nitrogen, and boron? Let's say neon. The electronic configuration for neon is 1s2, 2s2, and 2p6. In this case, we're going to have the first shell carrying two numbers of electrons, 1 and 2, meaning that we're done with the first one. 6 plus 2 is simply going to be 8. Therefore, the second shell can carry everything. Since we said the first shell carry 2 numbers of electrons, second shell carry 8 numbers of electrons. Here we're going to have 1 and 2. 2 multiplied by 2 is simply going to be 4. Here is going to be 1 and 2. 2 multiplied by 2 is going to be 8. In this case, for the neon, the valence electrons is simply going to be 2, 4, 6, 8. It's going to be 8. What about nitrogen? The electronic configuration for nitrogen is nothing but 1s2, 2s2, and 2p3. In this case, notice that the first shell is going to carry 2 numbers of electrons. Second shell, 3 plus 2 is simply going to be 5. Therefore, we're going to have 1, 2, 3, 4, and the last one, which is the fifth one. What about boron? The electronic configuration for boron is 1s2, 2s2, and 2p1. Feel free to pause the video and try it yourself. I hope you find it helpful. Thank you for watching. Feel free to like, share, and subscribe.